So let's talk about experimental determination of order of the reaction. Suppose we have a reaction happening in a container, and we can measure the concentration. Okay, let's say at time t1 we take out, suppose any reaction is happening at time t1 we take out and we find the concentration x1. Time t2 we take out and we find the concentration x2. At time t3 we take out, we find the concentration in is x3. Okay, this is the concentration of reactant. Okay, so let's talk about the very first one, hit and trial method. Hit and trial method. So in hit and trial method, let's talk about zero order reaction first. If we in the rate, if it is zero order reaction, if it is zero order reaction, then if we will what do, we will take x1, it will be k1 and t1. We'll calculate the value, we'll take the value of x2, that will be k2 into t2, and we'll also calculate the value x3, that is k3 into t3. Now if we will compare the value of k1, k2 and k3, k1 if it is k2 and k3, if we find all three value equal, then the reaction is zero order reaction, then it is a zero order reaction. That's how we will determine about the zero order reaction, and it is known as hit and trial method. Now let's take the second method. Now let's take another reaction, another order. Let's the order is first order. The reaction is first order. Okay, so now we will again compare the value k1. We will put in the t1 ln a divided by a minus x. Then we will put the value of k2. It is 1 by t2 ln a divided by a minus x. To now we will see k3 equals to 1 by t3 ln a divided by a minus x3. Now here we talk now on what is x1, x2, and x3, x1, x2, x3 is the amount of reactant product form. Okay, this is product formed at t1, t2 and t3. Now if we compare again the value of a1, k1, k2, k3, k1 equals to k3 we find, then we will say the reaction is of order 1. The order of the reaction will be 1. So that's how we will compare the first order and second order reaction. We have also equation for third order reaction. Then again we will put in the equation and we will compare the value of k1 and k2 and k3. If we find them equal, so that will be a third order reaction, second order reaction. Now let's talk about another method to determine, that is known as graphical method. Graphical method. In graphical method, first we will see what are the curve for zero order reaction. Okay, now time, if we draw concentration of reactant versus time, now we will know it is a gradually decreasing with a linear curve. Okay, now again if we talk about the concentration of product versus time, so it gradually increases from origin with linear. Okay, these are the linear curves. So that's how we will talk about the zero order reaction. That's how we name it as a zero order reaction. Now if we draw a curve for first order reaction, if we draw a curve of first order reaction, now how the curve of first order occur, if we talk about product versus time, so the concentration gradually decreases with the exponentially. Okay, now if we talk about the concentration of reactant versus time, now it increases, the curve increases exponentially. If we talk about ln, If we talk the ln a minus x versus time, then it is a linear decreasing curve. Okay, this is a time, and this is these three curves we get from first order reaction. Now we have one more method to calculate the order of the reaction, that is the half-life method. Half-life method. We already seen the t half of any equation is inversely proportional to 1 upon a into n raised to the power n minus 1. So suppose in experiment number 1 we get a1, concentration of a1, that is t half 1. Experiment 2 we get a2, that is t half into 2. Okay, so now concentration a1 and t time half time is t1. Experiment 2, the initial concentration a2 and half time is t2. So if we divide both of them t1 by 2, if we divide both of them t1 by 2 for first order divided by t1 by 2 for second order, that will be a2 by a1 raised to the power n minus 1. And 2 by a1 raised to the power n minus 1. Now we will take a log, and we will 1 plus log a ln t2 t half 1 divided by t half 2 divided by ln a2 by a1. Okay, that is for nth order reaction. This is the nth order reaction. Okay, again we have another method, last method, that we call it as a ratio variation method. This is an important method. Okay, this is known as ratio variation method. Now in ratio variation method, concentration of reactant change in definite ratio. Okay, here concentration of reactant change in definite ratio. Concentration of reactant change in definite ratios. Let's say A plus B is given C, and we take the concentration of A and B and rate of the reaction in meter mole second inverse. Okay, let's say it is 1 molar and it is 2 molar. Let's say it is 1 molar, it is 4 molar, and it is 2 molar and it is 4 molar. Then rates, let's say, comes out to be 4 into 10 to the power minus 4, 8 into 10 to the power minus 4, and 8 into 10 to the power minus 4. Let's say these are the rate and these are the concentration. So we will see. Now if we see the first equation and second equation, if we see first equation and second equation, we have kept the A constant. Okay, here A is constant, and we have doubled B. When we have doubled B, the rate of the reaction gets doubled. So here we can figure out R equals to K into B. It is the single power of B, because the concentration of B have doubled and the rate of the reaction is doubled. Now if we see the third and fourth equation, we have double the concentration of A, and we have kept the concentration of B same, and the rate of the reaction is same. So here we can conclude that rate of the reaction doesn't depend on the concentration of A, and it depends on only on the concentration of B. Okay, now also we can do it by, if we can take rate of the reaction as R equals to K A to the power X and B to the power Y. Okay, A to the power X and B to the power Y. So A to the power X, if we put the value 1 molar raised to the power X and 2 molar raised to the power Y, and it is 4 into 10 to the power minus 4. It is 8 into 10 to the power minus 8 equals to K 1 to the power X and 4 to the power Y. Now if we divide them by both, we have another equation, 8 into 10 to the power minus 4 equals to K 2 raised to the power X and 4 raised to the power Y. Now if we divide first and second equation, we will get y equals to 2 and x equals to 0. Okay, we will get the value of x equals to 0 and y equals to 1. So here also we can calculate rate on a raised to the power 0 and b raised to the power 1. Okay, this is an important method where we can, this is a ratio variation method. This is an important method by which we calculate the rate of the reaction by some experimental data.